So last class we talked about how to write polynomial functions given the zeros and their multiplicities. And today we're going to kind of expand on that topic, and we're going to talk about how we create a sketch of polynomial functions. So we're going to go through an example together, and then I'll have you do some practice on your own after. And so if we're looking at the function f of x equals x minus 2 quantity squared times x plus 1. In order to sketch these polynomial functions, we're going to look at kind of four important aspects of it. We're first going to look at the zeros and their multiplicities. We'll look at the y-intercept. We'll look at something called an f of x number line, okay, and we'll talk about this a little bit more. That's going to help me actually figure out the shape of my graph. And then we're going to look at the number 4, the end behavior of our function, which we did in Unit 1, okay? And I think you guys looked at that a little bit on your homework last night, too. So if you look to the graph on the right, what you'll notice is that there's no scale on the y-axis. And this is why we call this a sketch, because we're only going to be creating sketches of the polynomial functions that have the important information, and they're not necessarily going to be to scale exactly. All right, so let's get started in actually figuring out how to sketch this graph. So if we look at the first step, it's going to be to find our zeros and multiplicities, which we talked about last class, given a function in factored form. Right? So as we see, f of x is actually in factored form, so we can read the zeros off right away. I know there's one zero at 2, 0, and there's another 0 at -1, 0. And thinking back to last class, I know that because there's an exponent of 2 right here, then my root, 2, 0, has a multiplicity of 2, okay? My root -1, 0, we know that there's kind of an imaginary exponent of 1, we just don't really write it. So -1, 0 has a multiplicity of 1. And thinking back to last class, multiplicity is the number of times that 0 occurs. Right, so since 2, 0 has a multiplicity of 2, it occurs twice as a 0 of my function. And I'm actually going to go right away and plot these on my graph just because I can kind of keep track of my progress here. So I have a 0 at 2, 0, and then I have a 0 at -1, 0. Sorry, I don't know why that's moving. Okay, there we go. So we can go ahead and remember the zeros cross that x-axis, so we can go ahead and plot those zeros right there. And next we're going to look at the y-intercept. And so we've done this a lot in class. If we remember, the y-intercept is just the same as evaluating actually in your function f of 0. So if I plug 0 into my function f of x, I get 0 minus 2 quantity squared times 0 plus 1. And if I simplify that a little bit more, I get -2 squared times 1. And a -2 squared is a positive 4, and 4 times 1 is 4. So I know that my y-intercept is 0, 4. Right? And transferring that onto my graph, notice again, I don't really have a scale, but I do know that that y-intercept is going to lie above the x-axis. So I'm just going to kind of put an estimate of where it is on the y-axis. So finding the zeros and the multiplicities in the y-intercept is kind of review because we've already talked about that in class. And this f of x number line, that's really the new piece of information that we need in order to graph. So like I said before, the f of x number line is going to help us figure out the shape of our graph. And so what we're going to do is we're kind of going to look at almost like a mini x-axis and figure out what's going on here, right? But let's think about the name first, right? If I think about f of x, in previous classes, we've kind of used that as a synonym for saying y, or for saying the outputs of the function, okay? And what I'm really going to figure out is when is my function f of x, when are the outputs positive and when are they negative, right? So when they're positive, they're going to lie above that x-axis when my y values are positive, and when they're negative, they're going to lie below the x-axis. And this is what I'm going to do to figure out the shape of my function. So to fill out my f of x number line, notice if my function is negative, right, and it's going to become positive, then notice it has to cross that x-axis. So I would get a 0. So I'm going to use that to kind of help me figure out the shape of my function. So on your f of x number line, I want you to label the zeros. I have -1 and 2, okay, because those are going to determine the sign of f of x. When we fill out the slope, the f of x number line, we're really going to look at kind of each of these as a different region. So we kind of have like region 1, region 2, and region 3. And we're going to test each region to figure out the sign of my function, right? So if I pick kind of a point to the left of my 0, right, I'm maybe going to pick -2, right? So f of -2. That lies to the left of my 0 at -1. And again, all I really care about is what's the sign of f of x going to be? And we can figure that out by kind of testing this point -2 and putting it into our function, right? So when we plug -2 into the first factor up here, we get a -2 minus a 2, right? That's going to still be negative, but then when we square it, we actually get a positive answer. Okay, so in that first factor, I have a positive, I'll get a positive number, right? Now what happens when I plug in -2 into my second factor, right? -2 plus 1 is actually going to be a negative. It's namely -1, but again, I really only care about the sign because I'm trying to figure out, are my f of x values, are they positive or are they negative? So here I have, when I plug in -2, I know I'm going to have a positive times a negative, so my whole sign of f of x is going to be negative, right? And that is actually going to work for every x value that's less than -1. So I could, if you don't believe me, test it out, right? Plug in f of -3, and do you still get a negative? Plug in f of -30, right? And do you still get a negative? So we only need to test one point in that region 1 to convince us, well, what is the sign of f of x? All right, let's take a look at region 2. So I'm going to look at what's happening between the x values of -1 and 2 between my zeros. I'm going to make it easier for myself. I'm actually going to pick, well, 0 lies between -1 and 2, and we've kind of already done the work for this, right? We already figured out that's the y-intercept, which is 4, okay? So I already know that this region, f of x values, are going to be positive. They're going to lie above the x-axis, because I know my y-intercept was positive. And some of you might actually be able to look at the graph and kind of see that a little bit already because we've already plotted the y-intercept onto the graph. And then my final step is to test that last region, region 3. So again, I'm going to pick a number to the right of 2, and I'll test, let's say, f of 3, right? So when I plug in 3, in my first factor, notice I'll get a positive answer. 3 minus 2. Okay, we're kind of working up here a little bit. 3 minus 2 is 1. 1 squared is 1, so that's positive. When I plug in 3 here, I get 3 plus 1. That's 4. Well, that's also a positive. Okay? So my f of x values for x is greater than 2 are going to be positive. So just to summarize kind of what we did in part 3 of the finding the f of x number line, my goal was to figure out the shape of f of x. And I did so by figuring out when is f of x going to be negative and when will it switch over across the x-axis and become positive again. And you'll see how we'll put it all together when we sketch. But before we do that, I actually want to look at that last step of our end behavior. Okay, so remember from Unit 1, end behavior is what happens as x is approaching infinity, as the x's are getting really big, and what happens as x approaches negative infinity. Okay, how does my function move? And actually, we've already done all of the work for this, right? We can actually use the slope number line to help us out. So as x approaches infinity, looking at our slope number line, I've already determined that your x values here are positive, right? So that means that my f of x is going to approach infinity, right? If you don't believe me, test it out, right? Take maybe f of 50, right? And see, is that positive and is it getting bigger? And what you'll see is that it is, right? And plug in f of 100, right? What's happening? F of x is getting even bigger, okay? So as x approaches infinity, that f of x is approaching infinity also, okay? So let's look at as x approaches negative infinity now. So as x approaches negative infinity, what's happening with f of x? Well, again, let's look back at our slope number line. So as x approaches negative infinity, that's my left arrow going to the left. And here I can see in region 1 that my x values are negative. So as x approaches negative infinity, f of x is going to also approach negative infinity. So now I've done all the work that I need to before I actually go to sketch. So if you haven't already, take numbers 1 and 2, take your zeros and your y-intercept, and plot them onto your graph like I did, because we're going to finally kind of get to step number 5 here, which is to transfer all this information to sketch. So I already have my zeros and my y-intercept plotted, and really the bulk of this sketch is using this slope number line to figure out the shape of my graph. Okay? Now remember, when I say f of x is negative, I mean it lies below the x-axis, and when I say it's positive, it lies above the x-axis. Okay? So if we look at our f of x number line, as x goes from negative infinity to negative 1, my function is going to lie below my x-axis. Right? And then at negative 1, it switches over to positive, so it has to cross the x-axis and head up towards my y-intercept. Okay? But now, between my x values negative 1 and 2, my function is still positive, but I have to head back down towards my 0, right, at 2. Right? And then we have to kind of analyze our f of x number line here and say, okay, well, what's happening at 2? I know that my function needs to touch the x-axis at 2, but if you look at the signs, it actually, f of x always stays positive. So I always need it to stay above the x-axis, right? It will come down to 2, but it's actually going to come back up, right, and stay in the positive region, right? Now let's check our end behavior, okay? Let's see, as as x is approaching infinity, is f of x approaching infinity? Yeah, right, we're good. So that end behavior was good. As x approaches negative infinity, is f of x approaching negative infinity? Yes, okay? So this is how I use that slope number line to help transfer and see the shape of my graph and what's happening here. Right? And you can actually go back and check, right, between negative infinity to negative 1, right? My f of x values are negative. Between 1 and 2, my x values are positive. And between 2 to infinity, my x values are also positive. Okay? So this kind of concludes the graphing example for this. But there's one more thing that we need to talk about, and that's going to kind of come over here as some notes in that little star on the bottom right. So the next thing that we're going to talk about is kind of a little bit of almost a shortcut in order to graph, or another way to check to make sure that your graph is correct. Right? So we're going to look at two different cases. We're going to look at what does it mean to have an odd multiplicity, and then what does it mean to have an even multiplicity. Okay, so looking at our example in f of x, we can see that the 0, 2, comma 0, well, since that's a multiplicity of 2, that's going to be an even multiplicity. Okay, and negative 1, comma 0 had a multiplicity of 1, and that's going to be an odd multiplicity. But what does that mean in terms of our graph? In a couple of examples that we're going to do, you'll notice that when I have an odd multiplicity, that's actually going to mean that my f of x function is going to cross my x-axis, right? So if you notice looking up at our function, f of x has actually crossed at that odd multiplicity at negative 1, okay? And even multiplicities, like 2, comma 0, we like to say that they bounce. Okay? So they don't cross the x-axis, but they actually bounce off of the x-axis and head back up in the same direction. Right? And so in the next example, I'll show you how you can actually use this idea of odd and even multiplicities to create that f of x number line. All right, so let's look at this example together. This example is going to go a little bit quicker because we kind of already did the introduction. So I'm just going to walk you through these steps in another example, and then I'm going to have you practice example 3 on your own. So we're given the function w of x equals x minus 5 times x plus 2 times x minus 4 squared. So again, this function is in factored form, right? In example 3, you're going to actually have to put the function in factored form, and I can kind of help you out with that to help start you off. But here we already have our function in factored form, so I know that my zeros are 5. We have 5, comma 0, right? And this has a multiplicity of 1 because our exponent is 1. We have a 0 at negative 2, comma 0, and this has another multiplicity of 1. Right? And then finally, we have a 0 of 4, comma 0, which has a multiplicity of 2. Okay? And thinking back right to the end of our last example, right? This is an odd multiplicity at 5, 0. Another odd multiplicity at negative 2. And remember, those odd multiplicities are going to cross the x-axis, right? And then this is an even multiplicity. And this is the example where it's going to bounce off the x-axis. And you'll see what I mean when we get down to fill out the slope number line. The f of x number line. Okay? So now that I've found the zeros and the multiplicities, my next step is let's figure out our y-intercept. So again, that's evaluating f of 0, and I get 0 minus 5 times 0 plus 2 times 0 minus 4 squared. Simplifying that, we get negative 5 times 2 times a negative 4 squared, right? Which will simplify down to a negative 160. So my y-intercept is 0, comma, negative 160. Right? Let's transfer this, let's pause here and transfer this over to the graph. So I have a 0 at 5, comma 0, negative 2, comma 0, right? And 4, comma 0. And then my y-intercept is down here at 0, comma, negative 160. And remember, we're not drawing these graphs to scale, so it's okay that it doesn't really seem like 160 is in the right place because it's a much bigger number. All right, and our next step now is to create that slope, that f of x number line. So remember, we look at kind of the x values and we mark off our zeros. So we have a negative 2, a 4, and a 5. And we're going to test the region so that we can figure out the sign of f of x. Right? So if I test here, let's say we'll do like f of negative 3. And you could have picked another number like negative 4, negative 5. But when I plug in f of negative 3 in my first factor, I'll get a negative, right? Negative 3 minus 5 gets me a negative. negative 3 plus 2, that's still going to get me a negative number, right? And then a negative 3 minus 4, that'll be negative, but I'm actually going to square it. So this is actually going to be a positive number. So in this region from negative infinity to negative 2, I'm going to have a negative times a positive, which gives me a positive answer. Okay, and now I told you at the end of the last example that I was going to show you how to use the idea of bouncing and crossing for even and odd multiplicities to fill out the rest of the slope number line. I mean the f of x number line, sorry. So in we'll always have to kind of determine one sign for the f of x number line. But now, looking at the multiplicities, I know that negative 2 has an odd multiplicity. So that means it's going to actually cross the x-axis and go from a positive to a negative, right? Because we know when our function crosses the x-axis, it changes signs, okay? And then if we look at 4, well, 4 has an even multiplicity. And if you remember, that means it bounces. So my function is going to kind of travel back up to 4 and then just bounce off, and it's actually going to stay negative. Okay, so the region between 4 and 5 is still going to be negative. Right? And finally, my root 5, 0, that has an odd multiplicity, which means it's going to cross. So it's going to cross from a negative to a positive. And again, this is just another option to figure out the f of x number line. You could have, just like our last example, gone back in and tested each region, and you would have gotten the same results. So if this is not something that you like, you can still always test those regions. Okay, and then finally, let's look at our end behavior, right? So as x approaches infinity, right, from our slope number line, or our f of x number line, we can see that f of x is going to approach infinity, okay? And as x approaches negative infinity, we can see that our function, again, is still going to approach its positive, so it's going to approach infinity, okay? And now let's transfer that over to our graph. So from negative infinity to negative 2, my function is, this is positive and this is negative. My f of x function is positive. At negative 2, it crosses the x-axis, and we head down to our y-intercept, okay? Then we'll head back up to our zeros, and at 4, right, we're just going to bounce off the x-axis and then cross over at 5, okay? So we were positive up here, we were negative between here, we bounced off and we're still negative, and then we crossed over and became positive. Right? And so this is just a sketch of my function w of x. And actually, if I was supposed to be consistent, this should have been a w, okay? And this should have said a w of x number line. So try to be consistent with your function notation. Sorry about that. So I want you to try example 3 on your own, and I want you to sketch a graph using the guidelines from the previous problem. So what I mean by guidelines is you need to make sure you have all of that important information. You have what are the zeros, right, and their multiplicities. What's that y-intercept? You need to create the f of x number line, right, and you need to look at the end behavior, okay? But I want to help you, start you off a little bit. And notice that before in the other examples, my function was actually given in factored form, and now here I have a function that's written in standard form. So remember, when we're changing from standard form to factored form, the first thing you want to look for is, let's pull out a GCF. And in this case, I have a GCF of x. So when I take out that factor of x, I'm left with x squared minus 4x plus 3. Okay? And now we can use our factoring skills from Algebra 1 to change this term in here to x minus 3 times x minus 1. Okay, so now this example should look a little bit more similar to the ones above, and I want you to try those on your own. All right, so let's pause the video here, and then you can actually do the work, and then you can go check your answers online after. All right, good luck. and I'll see you in class.